Hi, and welcome to this video on applications of proportions. Now, we've previously talked about solving proportional equations. Now, remember, a proportional equation is basically an equation that looks like this: a fraction on one side, a fraction on the other side, and an equal sign. Now, those fractions could be ratios, which is a fraction with the numerator and the denominator have the same units, or it could be rates, where the numerator and the denominator have different units. Generally, when we see applications of proportions, we're going to see rates rather than ratios. So in this presentation, I'm going to go through 5 problems, and you're going to see a lot of similarities between the 5 problems because this is a very specific type of equation. A proportional equation has to look literally like this. A and B and C and D could be any numbers, could be decimals, could be fractions. The only exception is this number on the bottom and this number on the bottom. They can't be 0. Can't be 0. Okay, so that's something we've discussed already. So now let's take this idea of solving proportions and use it to solve equations or to solve word problems. So in this first one, it takes 70 ounces of grass seed to seed 3,640 square feet of lawn. Right? So that right there, let me just focus in on that one statement. 70 ounces of grass seed, right? To do 3,640 square feet of lawn. So there's a rate, right? There's a single rate. 70 ounces. It goes with 3,640 square feet. All right, so that's a rate. It's not a unit rate, but it's a rate. At this rate, how much will be needed to seed 6,000 square feet of lawn? So basically, if you look back over here on the right, in a problem like this, an application where we're using a proportion, we're usually going to be given 3 of these numbers, and the 4th one is going to be unknown. It's not always going to be the bottom number on the right, but there's going to be 3 numbers given and 1 number missing. And that's what we're looking for. What is that missing number? Right? So to solve a proportional equation, in this case, our fractions are looking like this: ounces on top, square feet on the bottom. Now, I'm just using ounces on top because it came first in the sentence. You could put ounces on the bottom. It doesn't matter. You just have to be consistent. Right? So each fraction is going to look like this. And so when we set up our equation, the first fraction is a rate that's given. Right? So we've got 70 over 3,640. Okay? And the other half of that equation, I'll use a different color up here. At this rate, how much will be needed for 6,000 square feet? Right? So that's the half of the second rate. Right? Half of the second fraction. That's square feet, and I have labeled square feet goes on the bottom. Okay? So for that second problem, 6,000 square feet. And the unknown here, I'll use the letter X as a temporary placeholder for that unknown. It's the number of ounces, right? So that's the question. At this rate, how much would be needed? So how much what? We're talking about grass seed. How many grass seed? How many ounces of grass seed, right? So there's our proportional equation. That's the setup, right? Now it's, if you're looking at this, it's no longer a word problem. We've translated the words into a mathematical equation. So that's sort of every word problem has a phase 1 and a phase 2. Phase 1 is setting up the equation, and then phase 2 is solving the equation. So phase 1, the setup, that's where you're translating English to math. Right? That's what we did. We took the problem, we translated it to a mathematical equation. So now, at this point, again, no longer a word problem. So now we have to solve this. And I'm not going to take too much time talking about how to solve proportional equations. That's something we just finished discussing in our previous class. So now that we have a proportional equation, step 1 is cross multiply. The cross multiplying will eliminate the fractions in the problem. So if we multiply x times 3,640, we have 3,640 times x. And on the other side, we've got 70 times 6,000. Now, I'm no longer using a little x for multiplication symbol because I'm using x as a variable in the equation. So I'm going to use the dot symbol for multiplication from here on out. So on the left-hand side, we've got 3,640 times x. And on the right, if we multiply, now I have a calculator off screen. You can't see my calculator, but if you pop this into a calculator, 70 times 6,000, that's going to be 420,000. Right? And we want to solve for x, so we need to eliminate the 3,640 that's being multiplied to the x. So right now, we have 3,640x. We want x by itself. So anytime we want to eliminate, we basically want to do that. We want to get rid of that number, right, in front of the x. So anytime we want to remove or eliminate a piece of our equation, we do the opposite. The opposite of, in this case, the opposite of multiplication is division. So I'm going to divide by 3,640. Now, right now, x is being multiplied and divided by the same number, right? Any number over itself is equal to 1, so they cancel. Now, the only way we're allowed to do this is if we balance it off by doing the same thing to the other side. So if I divide the left by a number, any number other than 0, I have to do the same thing to the right. So I'll divide the 420,000 by 3,640. Notice I'm setting it up as like, it looks like a fraction. Fraction means division. So on the left-hand side, let's see, we've got x. And on the right-hand side, if you take 420,000 divided by 3,640 and you put that into the calculator, you'll see on the screen 115 point, let's say 3,846,15. Just at any point, please pause the video and verify this on your own or work along on your own. Now we go back to the question, to the original problem, round to the nearest whole number, right? Round to the nearest whole number. So that first decimal place is a 3, which means we don't round up. So our answer here would be x is equal to 115. Well, the answer to the original equation, the original problem is using words. Our final answer should also use words. So the question is, how much would be needed? We could say 115 ounces of seed is needed. It's always a good idea to express your answer in the form of a statement, right? It's a word problem, word answer. All right, so that is it. That's solving an equation using a proportion. All right, let's look at number 2. A label prints 8 pages of labels, or sorry, a label printer, sorry, prints 8 pages of labels in 4.2 seconds. Okay, if you stop there, that's a rate. That's a full rate. Now that's 2 units, number of pages and number of seconds. So if I'm looking at this first sentence, we're talking about a rate in pages per seconds. Okay, and so we're given that 8 pages are done in 4.2 seconds. Now, how long will it take to print 50 pages of labels? All right, so we're given number of pages, and the way I have this set up, remember, we have to be consistent. So if I've got pages on top and I'm given 50 pages in the question, the 50 has to go on top. If your X is in the wrong position, you will get the wrong answer 100% of the time. So that's why it's important to, I start off by just labeling what my numbers stand for. Anything on the top of a fraction, I'm using number of pages. Anything on the bottom, I'm using number of seconds. So now we have got a proportional equation, and we can cross multiply. 8 times x is equal to 50 times 4.2. Now we could go to a calculator and say, okay, what is 50 times 4.2? That's 210. And just like in the last problem, we want to eliminate the x. Right now, x is being multiplied. We want to eliminate everything else other than the x. So x is being multiplied by 8, so we're going to divide by 8. And we have to do the same thing to both sides. On the left, the 8's cancel. So we have x equals. And then on the right-hand side, if we take 210 divided by 8, we are going to get 26. Let's see. 26.25. The question doesn't say anything about rounding. And in this case, we don't have to round. The decimal stops after 2 places. It doesn't go on forever, so we don't need to cut it off. So there's our answer to the equation, 26.25. So the answer to the word problem, I'm going to say it takes 26.25 seconds. Remember, word problem, word answer. All right, next one. Now you're gonna, as we work through these problems, we've done 2, there's 3 more. You're going to see they're very similar in terms of the mechanics of how we set it up and how we solve. The scale on a map is 1/4 inch to 5 miles. So we have distance on map, we've got distance in real world, right? So that's our rate. We've got inches. Let me switch back to blue for now. We've got inches. And we've got miles. So the rate that we're given is 1/4 of an inch goes with 5 miles. So there's half of our proportion. And the question is, find the actual distance, so find the number of miles between 2 towns, which the distance is represented by 39 inches on the map. All right, so we're given 39 inches. I've got inches on top. My X is going on top. Oh, sorry, 39 inches. My 39 is going on top. We don't need to use X for a number that we know, right? X is a temporary placeholder for a number that we don't yet know. Find the actual distance, that's number of miles, that's X. All right, so there's our proportional equation. And we can cross multiply. 1/4 times X is equal to, we'll cross multiply the other way, 39 times 5. Now, this 1/4 times x, I'm going to write that in a more compact form. A fraction means division, so multiplying by a fraction is the same as, multiplying by the fraction 1/4 is the same as dividing by 4. So I'm going to write that as x over 4. That's the same as 1/4 times x. So you could also think about it like this, 1/4 times x. Well, we could write that like 1/4 times x over 1. And if we multiply top times top, bottom times bottom, There's another way of looking at x over 4. Okay, and on the right-hand side, 39 times 5, that will give us 195. Now, we're solving for x, and right now x is being multiplied. X is being divided by 4, so we want to do the opposite. We want to multiply by 4. And if we do it to one side, we got to do it to the other side. And on the left, those 4's cancel. So we've solved for x. And on the right-hand side, if we take 195 and we multiply that by 4, we get 780. So we could say the towns are 780 miles apart. So that would be my final answer for this problem. If a string stretches 3 meters when a 6 kilogram weight is attached to it, how much will it stretch when a 24 kilogram weight is attached to it? Well, if we want to visualize this, and I like to draw a sketch whenever possible, and I don't know how often this comes up in real life, but just imagine a ceiling and then there's a spring attached to the ceiling, and at the bottom of that spring, there's a weight. And so what we're told in the beginning of the problem, if a spring stretches 3 meters when a 6 kilogram weight is attached to it. Right, so it looks like, let's see, the 6 kilogram weight is here at the bottom, and the spring is stretching 6 meters. How much will it stretch when a 24 kilogram weight is attached to it? Well, a heavier weight, you think, might pull the spring down a little bit more. So maybe something like this. We'll draw a bigger weight down there. Let's say this is 24 kilograms. And the question is, how far is the spring stretching? Now, you don't need the diagram for this one. I like to draw a diagram when possible. So back to the problem, we're talking about meters and kilograms, right? So that's our first rate. Meters, I'll put meters on top. Again, just because it comes first in the sentence is my preference. There's no reason not to, but you will get the correct answer if you put meters on the bottom and kilograms on top. That doesn't make any difference. All right, so our first rate, 3 meters, goes with 6 kilograms. How many meters go with 24 kilograms? And so we're given kilograms on the bottom. So our second fraction, we'll have 24 on the bottom, x on top. All right, now that we've got our equation, now we can solve. So we cross multiply. 6 times x, so that'll be 6x, and on the other side, 3 times 24. And if we multiply out 3 times 24, that should give us 72. Okay, so 6x is 72. We want to know what is 1x. So eliminate the 6. Right now, x is being multiplied, so we do the opposite. Divide. Whatever we do to one side, we've got to do to the other. So on the left, those 6's cancel nicely. Now we have x equals 72 divided by 6 should give us 12. Again, this is the answer to this equation. The answer to the word problem should be a statement in words. So we could say the spring will stretch 12 meters. And that should do it for this one. right, so I think I got one more lined up. As a nurse, part of your daily duties is to mix medications in the proper proportions, keyword proportion, for your patients. So there's a little bit more text here, but it's the same type of problem, right? For one of your regular patients, you always mix medication A with medication B in the same proportion. Last week, your patient's doctor indicated that you should mix 90 milligrams of medication A with 117 milligrams of medication B. So what we see here is not a rate. This is what we call a ratio. So we've got milligrams of medication A, milligrams of medication B. All right, so same units, milligrams, milligrams. But we have to be specific because it's two different medications. So we could say we'll make a fraction milligrams of A on top and milligrams of B on the bottom, right? And so that first pair of numbers we're given is 90 milligrams of A goes with 117 milligrams of B. 90 and 117. That's half of our proportion. However, this week, the doctor said to use only 39 milligrams of medication B. So 39 milligrams of medication B, I've got milligrams of B on the bottom. So that 39 is on the bottom of the next fraction. How many milligrams of medication A? So that's our unknown, that's our question mark, that's our X. Right, milligrams of A on top, milligrams of B on the bottom. Now we've got a proportion. We can cross multiply. So we've got X times 117, or 117X, is equal to 90 times 39. And if we multiply that out, 90 times 39, that will give us 3,510. All right, one more step. We need to solve for X. Right now, X is being multiplied, so we have to cancel off that multiplication with a division. Divide both sides by 117. On the left, the 117s cancel, leaving X. Solve for X. And on the right, if you divide 3,510 divided by 117, you will get 30. So again, there's our solution for X. To give the solution to the original problem, we should say 30 milligrams of medication A should be used. Now, I didn't check our answer for each of these 5 problems. Well, one, because I know they're right because I worked them out ahead of time. But I think at least once, let's just make sure we know how to check our work. Right? And so the way we check our work is by using a unit rate. Using a unit rate. And a unit rate is what we get when we take a rate and we put it into a calculator. So the first rate that we used was the 90 divided by 117. And the second rate was x over 39, but we figured out x, remember, x is a temporary placeholder, right? We started off not knowing what x is. Then we figured out x equals 30, right? So this 30 is the number that goes right here for x. Right? 30 goes in for x. So the 90 over 117 and the 30 over 39. If 30 is the right answer, then when we divide in the calculator, 90 divided by 117 and 30 divided by 39, we should get the exact same number. So I'm going to pause the video here for a moment and figure out that. That's a calculator problem. 90 divided by 117 equals, you'll get a decimal. And then do the same thing, 30 divided by 39 on the calculator, you'll get a decimal. If we're right, those two question marks, those two decimals on the calculator should be the exact same number, right? And that's one way, well, that's a good way to check our work to make sure our answers are correct. All right, so that does it for this. This video was not much of a lecture, an explanation. This was more of an application. We previously discussed what is a proportion, what is a rate, what is a ratio, how to solve generic proportional equations, and now in this video, I think we did what we needed to do, applied the ideas of proportional equations. All right, that's it for now. I hope this was helpful.